we are now going to dive into the programming section, which is at 6:50 on the dot. I've never looked at the clock, but I feel amazing about that right now. I don't know how often we do that, but it feels good. So Zev, I don't know how like hand and brain you want to do this. You want me to like talk through some of this, or you want to just navigate the whole thing and I'll drive?
Well, I've requested control. I don't know if we'll actually end up using it, but
Yeah, given.
we can give it a try. But yeah, if you want to drive, that might make it a little easier sometimes. If I'm talking and typing, I do both too fast, and then nobody gets anything out of it.
Sure.
So if you want to type, and we'll see how it goes. Um, so functional programming, definitely, as Matt said, a big topic. And I'm not going to be getting so much into the like really academic side of it, largely because I don't know it, or at least don't know it well enough to teach it. I do recommend a good resource for that. There's a book called it's like Functional Programming in Swift, or Swift Functional Programming, something like that. It's from the Objective-C.io folks. I will throw that in the chat. Functional Swift, and I'll warn you, it kind of bounces back and forth between super practical. Oh, hey, you have it on paper.
I do. I like paper books.
Cool. We did it. That was the inaugural book of the Swift book club that we did a few years ago in Boston. And then people got tired of doing homework, so we stopped. But anyway, it has super practical chapters like the stuff we're going to be talking about, and then alternating with like really esoteric academic chapters. So just like go into it knowing that if something doesn't make a lot of sense, you can probably skip to the next chapter, and you probably aren't missing that much in terms of practical, useful stuff. But it's interesting if you want to dig in. And so yeah, I wanted to stick to more of the practical things. Like there are parts of functional programming that have kind of seeped into pretty everyday Swift code, and I think it's really useful to understand sort of how to use these things and maybe peek under the covers a little bit and see how some of this stuff works, because I think it will give you a much better understanding of what's going on, figure out how things are breaking when they're breaking, and figure out how to maybe use some of this stuff to write your own things that may benefit from a functional style. So let's dig in, and definitely throw questions in the chat. Let me know if you missed something. There's a lot of it's going to be somewhat dense on things like syntax. So let's make a new playground to start stuff off in Xcode. And it's been so long since I made a new playground because I just keep one on my desktop. I think it's a different thing. I think it's like Command N instead of
file new
Command something else.
File new playground.
Many Command and many other keys N.
No.
So yeah, let's do a blank playground, and we're doing it as Mac OS because if you're not doing anything iOS specific, just use a Mac playground because it doesn't have to fire up an iPhone simulator, so it's a lot faster, more responsive, which is neat.
Also, I saw you call it out in chat. We do have a YouTube channel, so if you are trying to code along at home or want to go review anything that you missed and like you just can't keep up with what we're doing, I do my best to edit down the videos and then get them up onto our YouTube channel about 2 weeks after we have gone live. So in between that time, you can totally come back to the Twitch channel and watch this as a VOD, video on demand, BOD, however you want to say it.
OD.
Yeah. It's here.
Cool. If you could just whack up the font size a little bit, we're gonna not need. Yeah, we'll have. This is all we're looking at. So, okay. So playground. So let's get started with, I think, where a lot of people are introduced to functions in Swift. We'll start real basic and then start ramping up. Oh, could you switch the playground to run automatically, please? There, if you hit the little play button or click and hold it, and then switch it from manually to automatically, it'll just keep running as we type things. And you can actually delete everything that's in here right now. So I think where a lot of people get started with functions in Swift is like you have structs or classes, and they have functions on them, and you're calling them. So I think we'll start there and then kind of work our way up. So let's say we have a person struct.
Okay.
And maybe they'll have a name, a let name that's a string. And maybe they'll have a function. Let's start out with printing. So let's have a function called print hello. And this function will take no arguments and it will print the string hello, my name is, and then a name. And Matt's going to use something called string interpolation, where that backslash parentheses means take the value that's stored in that variable and put it into the string. And yeah, so let's see that in action. So let's make a new person. So like let Zev or Matt or whoever equals, and we pass in the name. And let's make a Matt as well because we're going to need it later. And then you can do so the function is on person. It is an instance function of person, which means you need to call it on a person. So zev.printhello asks the zev struct to run the printhello function, and playgrounds will explode. I think I had to restart Xcode like every 5 minutes or less while I was building this, just like my notes. Cool. So it printed it down in the console at the bottom. Yeah. Okay. And then we could add another function that takes an argument. So let's say we want to say hello to another person. So print hello to other person.
Zev, when we spoke, you stated in terms of variables you always use let for 90% of the time, and Xcode will yell at you if you need to use var.
Yeah, it's a pretty good rule of thumb to use let. If you have a let, if you're trying to debug something, you never have to worry about whether you like, oh, is this thing changed? I've got this variable and I think it's equal to one value, and then later I don't have to worry about whether it's equal to something else, because if it's a let, I know it never changes.
Oh no, my camera's over the console.
Oh no.
Thank you for that call out.
Right, we don't usually have. If you bring out the left sidebar, or just like move your window, because we're not going to be using the whole.
That's right. We line me with the left sidebar.
Let us know if that's if that looks better. So anyway, yeah, use a let. Let should be your default, and then you'll usually know if you need a var because you are going to be mutating something, or if you don't, yeah, you'll try to mutate something. Whoops, that's your computer. I want to quit an app on my computer because it's making noise. Let's see. Yeah, use a let and then use a var if you need to change something. Okay, cool. So we have this other function now, print hello to other person, and it let's see. Oh, I was gonna have it do like hello other person, my name is my name.
Oh, so you want the person?
Yes. Hello other person, comma, my name is.
Also, there was a question in chat, how did we do the automatic? If you hold down the play button, you can switch between automatic and manual.
Yep. And if you don't do automatic, you can hit Command Shift Return and it will run. But that's mostly set up for weird machine learning applications where you don't want to rerun the whole playground every time. Cool. So now we have a function that takes an argument. So when you call it, you're forced to pass something into it. And actually, would you mind retyping it and just show sort of what the interaction is there with Xcode? Because Xcode does some nice stuff to help you out. So it shows you the things that you could be auto-completing. And actually, I heard some confusion about this recently. So in this list, you're seeing two things. You're seeing a list of possible things you could call. So you could get Matt's name, or you could call those two functions on Matt, or you could do matt.self, which there's usually no reason to call self on a value. But then down below that, like the last row is kind of like documentation. It's showing you more information about the thing you have selected. So yeah, it's good to just know what you're seeing there.
Oh my god, I forgot a keyboard shortcut for everything I do.
That would have been Command Option /
Yes.
Cool. So Matt hit Command Option / and Xcode automatically filled in some / little template things. You fill out the form. And then when you are filling things in, it gives you the documentation, but it also just gives you the function signature, which can be really useful because when you're auto-completing there, print hello 2, you can't even see the type of 2. But then when you look at the doc down below, it shows you, oh, cool, it's a person. So that's also really useful. And then that trick is also option clicking on the option clicking on pretty much anything. It'll tell you what type it is or what type Xcode thinks it is. And then Matt, how are you getting that autocomplete thing to pop up whenever you wanted it?
Let's save that for next month.
Oh yeah. Command Option / was the shortcut.
The one that's above enter. If you, like me, don't remember the difference between back and forward slashes.
The one that's not above enter.
No, there's one above enter.
The one.
Wait. Nope, you're right. The one that's not above enter. If you, like
A
me,
forward
forget
slash.
what you just clicked.
Yeah, if a / when it's leaning, if it falls down, it falls forward in the text, and a / if it fell down, it would fall backward in the text. That's how I remember it. Anyway, cool. So these are functions. We have a function that takes no arguments. We have a function that takes one argument. Now I would like to write a function that returns something. And yes, you can use those docs to help explain what the function does. So I'd like to do a function that instead of print hello, I want to do hello string. So this will be give me back a hello statement as a string instead of printing it out to the console. And you can just copy in the same thing from the other function. Cool. So that didn't show anything down below, but it did put a little string over in the sidebar, which is a neat Playgrounds feature. And then we can, just for completeness, let's rewrite the other print hello as hello string to other person. I forget if I actually ended up using that in my sample code, but it's nice to just see how all the pieces fit together.
Oh, I see.
Yeah, like make a new function under hello string called hello string 2. The name is doesn't make a lot of sense, but it's okay. Oh, I guess we should also talk about inside names and outside names.
Sure.
I always think of like inside voice and outside voice when I'm talking about that. So in both of these functions, there's the word to inside parentheses space other person, and the first one is the name of the variable, or is the name of the parameter when you're calling the function, like on line 28 and 29. So it makes it read really nicely, zev.print hello to Matt. But then inside it wouldn't make sense to refer to that variable as to, so you can give it a name to refer to it inside the function, which just really cleans up and makes the code a lot more readable. Cool. So now we have functions that can just return strings instead of printing out to the console. And that's useful because we might not want to print it out right now. We might want to take it and use it somewhere else in an app, pass it to some other function, do whatever. So it's nice to have it as a string. We don't have to do this, but maybe as an exercise, if you're following along, you could rewrite the first two functions to use the output of the second two functions. Or we could do it. I don't know. It's nice to see how functions can like chain together. Yes. So let's move on. So let's make an array of people. So like let people equals, and put our 2 people in there. And let's option click on people just so we can see the type. So Swift has inferred this to be an array of person, which is cool. Swift does a lot of type inference for you. So it's nice to be able to check like what does Xcode think this is, because sometimes the answer will surprise you. And let's say we want to ask all the people in that array to say hello. So let me see. I'm looking at my. Oh yeah. So we can do a simple loop. Cool. Yeah. That's good to clarify. So if we do for person in people, and then person dot print hello. Maybe above that, just put like a print dash 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 so that we get a nice separator in our log. Cool. So we did the thing. And now let's say instead of just printing out the 2 hello strings, let's say we needed to put those in an array because we needed them somewhere else. So we have our array of people, and we want to get an array of their hello strings. So let's talk about a kind of like what's the first kind of obvious way you might write this, especially if you're coming from other languages or coming from Objective-C, which probably nobody is. But anyway, what you might do is, I saw you starting to type it. You might make an empty array. So var, what did I call it? Hello strings. And it's an empty array of strings. So we have this empty array, and then, nice. Yeah, I like that format better, but they're totally interchangeable. Can we, just for simplicity, can we move this down below the loop? There's like a new concept. Cool. So we have our empty array. You don't have to define the type of the array, Alex, if Swift can infer it. So line 36 is totally valid. You might add type information if it helps the reader. Like you always want to be thinking about who's going to be reading this code, which could include you in 2 weeks forgetting what you were doing, which is like really common. For most things, most of the time, you want to just let Swift do the type inference. And only like, it's not very confusing. Like, oh, it's an array called people. It's of type array of person. That's not surprising. Where you want to start adding type annotations is either where you need them, because for whatever reason, Xcode can't figure out what you're doing, or for clarity, if something is not clear.
There is a third reason, but it's like way down the road in a project where if you start having a pretty massive project, the compiler will get pretty slow, and doing the types for the compiler will speed it up because it's not doing the extra heavy lifting of trying to figure out what it is.
That's true. Although don't just start sprinkling types everywhere and assuming that it's better. Like you should measure before and after, because sometimes it helps, sometimes it doesn't. It still has to resolve the types to figure out if the type annotation that you put on is valid. So
yeah,
it's not a panacea. It's a mostly sia. Okay, so what were we doing? We're looping over people and putting their hello strings in this array. So we can do the same for person and people. And then get their hello string and append it to the array. And then maybe just print out hello strings. I always think of Marvin the Martian. Here I am, brain the size of a planet. Cool. So we printed out our array of strings. And that's totally fine, right? That code works. But there's a couple things that could be made better. We had to make it a var. And as we were talking about with some questions from the chat, it's nice to not have vars, because if this is a var, I always, if I'm having some problem, I always have to go think, so where are all the places this could have changed? Anywhere between line 42 and wherever I'm trying to debug, it could have changed anywhere in between there. So that's one thing. It'd be nice to do this without a var, but we had to use a var because we had to append on line 46, and you can't append. If you made that a let, it would yell at you about can't mutate a constant, basically. I don't know exactly what the error. Cannot use mutating member on immutable value. Hello strings is a let constant, and then it will even give you a fix it to say change it to a var. And that's what I mean about Xcode will help you figure out what you did wrong. So that's one annoying thing. The other thing is you kind of have to run a little program in your head to read this code. I mean, this one is obviously a very simple example, but like, once you start expanding this out into real code in a real app, you potentially could have a big chunk of code where you're reaching into a value to get a bunch of properties and then constructing something else and doing a bunch of transforms. And what could get lost in all that is I'm taking each thing out of the array, I'm making a new thing, I'm adding it back to the array. And Swift gives us a really nice function that basically is that. It is, look, you just give me a transformation from one type to another type, and I will handle all the mechanism of building the array and appending things and giving you back the array. And that's called map. And that's what we're going to look at right now. This was fun in the chat earlier in the Discord, because I was helping Alex with some map kit stuff. So we were talking about map and also map. Okay. There's always one like that. Okay. So let's write the same line of code. So we'll do the map, and then we'll dig in a bit to see what's going on and how it works. So let's do like let hello strings mapped. So there's a new variable representing the same idea equals people.map open curly brace. Yeah, we can do I don't know. I mean, basically fill in your preferred version of functional syntax, and we will go over all the different versions later. So yeah. So people.map, and then yeah, return what person.hello. Okay. So there's a bunch of stuff going on in this line, but just from the top, I'll say this one little construct is doing the same thing as a bunch of lines before, and we now get a let. And let's talk through what we're seeing here, and let's also figure out why it's not working. I think it's just stale. It's giving you a warning that makes no sense. Editor placeholder and source file, that's not real. So must be Xcode being Xcode. It is kind of amazing that we're 7 years into this and this is still like very common.
Yeah, but Playgrounds gets better every year.
Yeah, this is after 7 years of getting better.
It's a little aside while I'm pulling this back up. I keep a repository of Playgrounds. A little private thing that, anytime I'm trying to work through a problem, I'll just make a quick little playground for it. You talked about having a one that you always keep on your desktop. My equivalent of that is just a repository, so like a big folder with like, I think I'm somewhere around like 50 different playgrounds at this point, which is getting hard to navigate. But it makes it a little bit smaller, because I found the more code you put into a playground, the more error prone it becomes. So, small tip for you.
That's a cool idea.
Yeah, and then, I don't have to be like, hey, what was that thing I did 3 years ago? I've got a playground that, I mostly use it to like figure out ideas. It's not like full-blown apps or anything, but.
Yep. So we didn't have to print anything. We can actually see it in the little sidebar.
No, I think it's this one.
No, look at 51.
You're saying over here. Yeah.
Yep. I mean, we can print it if we want, but wow, that preview is really unhelpful. All right. the square also adds a viewer into the like inline, which is kind of neat. But oh, that's a good idea. We've got the space. So yeah, so what is map doing? And we'll get into the specifics of the syntax, like what is that person arrow string in business. But the gist here is that map is a function that says, hey, given an array of things and a transformation from that thing to a new value, give me back an array of new values. And that transformation can be digging into a type to get a property out. So in this case, we're digging into person to pluck out the name. It could be constructing a new type from the old type. I mean, those are really the two main kinds of transformations, but either one will work with a map. Map is just in general, given an array of things, tell me how to transform one of those things into a new value, and I will run that transformation on all the things and give you back the new array of all those things. So I thought it would be interesting to try building map as a way to kind of see how it works. Like it feels kind of magical when you're first using it, but it's actually neat to see how simple it really is. So let's give it a try. It might, we'll see how it goes. So let's put an extension on sequence. Let's write this as an extension on sequence. This is, I don't know if this is exactly how it's done in the standard library. I was gonna show you, if you option click on map, we can see some stuff about it. So we can see the signature of the function, and we're actually gonna need that. So why don't you copy that? And then can you scroll down? Does that scroll at all?
It's all of it.
No, neat. I was hoping it would show us like in the documentation where it's defined. You could try right-clicking on map and doing, right-click won't work in Playground, but if you command-click on map, I don't know why, and then do jump to definition, this jumps to, it's not exactly a header file, but it's like a generated file that shows you where things are defined. So you can see this is a specific version of map that's defined on array. But we can do one on sequence. Actually, it's probably out of scope of this presentation to talk about why, but if people have specific questions, we can talk about it. Anyway, so let's add a function called myMap. And let's just get rid of the throws and rethrows stuff. I feel like I don't really want to talk about that for this session unless there's specific questions. It's like it adds an extra layer of complexity that it's good to understand without that first. Yeah. Okay, so we have a function, and let's look at this at the signature. It takes a parameter called transform, and that parameter has a type of person arrow t. What does that mean? What's going on here? So this is Swift syntax for what's called a closure. A closure, that's CLOSURE, closure. It's one of those words that's hard to understand if you don't know how it's spelled. It's basically the same thing as a function. There are nuanced times and places where that's different, but the syntax is types of inputs, and that could be a list of things, but it's just one thing right now. Arrow output. And then what is this T? Where did T come from? We're not talking about T. So T is using a feature of Swift called generics. And I don't like using T. Let's give it a better name, like result or output or transformed, maybe transformed, because we're doing a transform. So you can call it whatever you want. But what you're saying is, think about what this function would look like if we didn't have a generic. You have a function that transforms a person into something and then returns an array of something. But what is that something? And generics are what let you specify what that is. They let you actually write, like, if you didn't have generics, you couldn't write this function. Maybe you would use any, like person to any returns array of any, but that gets rid of all the useful type information. So yeah, so we have a function generic over a transformed type. That's how you read that with the angle brackets. So my map is generic over a transformed type. It takes a closure. that turns a person into a transformed type. Whatever that transformed type is, we don't know. It will be supplied when the function is run, and it returns an array of that transformed type. Let's just, before we even write the function, let's call it basically the same thing as we did on line 51. Let's just copy and paste that below just so we can kind of see where we're headed. So we'll do .mymap, and array is a sequence, so we're allowed to run that function on it. Person transform into string. So this is where the generics come in. In this case, that transformed value is a string. It could be an int, it could be whatever. In this case, it happens to be a string. So if we run this, it should be an empty array because we haven't actually done anything yet. Okay, yeah, empty array. So now what we can do is we can actually start by copying and pasting the sort of naive var array version from line 42 and then start modifying it to get to what we actually want. So we're encapsulating that existing logic we already had. And then it used to be specifically about getting hello strings from people and returning arrays of strings. And we're going to sort of massage this code so that we remove all the specific type information and just do the generic thing. So first of all, the array is not going to be called hello strings. It's just going to be called like result or output. And it's not going to be an array of string. It's going to be an array of transformed. And now it's not for person and people. Oh, actually, yeah, that transform, that should be, sorry, I missed that. That transform from person to transformed on line 58 should actually be a transform from element to transformed. And where did this element thing come from? That's new. We haven't talked about that. So if you command click on element and jump to definition, you will see where it comes from. So yeah, we're in the Swift standard library under collection. Oh, cool. It put us in some random place that's not at all where we wanted to be. Sometimes
Font's too big.
Yeah.
Don't know
search
where
for
it
element.
is.
It's not that one. It's a different one. I mean, search for element in this file.
It's gonna be everywhere.
Oh no, there's 699 of them.
Yeah.
Yeah. Oh, if you pull up the documentation, which is another good thing to learn how to do under the help menu. Like up at the top of the screen, developer documentation, and pull up array, or actually sequence. So we'll find the documentation for sequence. Yeah, first one looks right. So sequence is a protocol, and if we scroll down to where it lists out all the types and stuff. Oh, here we go. Associated type element, a type representing a sequence's elements. So that's where element comes from. Yeah, if you have a sequence, it has an associated type element and a bunch of clauses that aren't important right now.
And what is an associated type?
So an associated type is like, now we're getting into protocols and associated types. These topics are deep and broad. So sequence is a protocol. Protocol is, if you're familiar with languages that have abstract interfaces, it's something like that. If you're not, protocol is a contract. It's saying, I don't know which type this is going to be, but I know it will be able to speak the language of a sequence or speak the language of a collection or whatever. And an associated type is, so I think it's easier to give a concrete example. So sequence has an associated type of element. So you don't just have a sequence, you have a sequence of string or a sequence of int. Yeah, you want to describe what you've done here?
Nope.
Cool. You want me to?
Yeah.
All right. That was bad timing for me to eat that yucca fry then. Still has to be a var. You can't have let in a protocol.
I thought so.
So yeah, brief digression into protocol. So a named thing is a protocol Matt's created, and we don't have to know what a named thing is. All we know is that a named thing will have a name property, and that name property will be a string, and you'll be able to get and set it. And so we can conform person to named thing, and we could conform pet if we had a pet type to named thing, and we could conform programming language. That's a little too meta. We could conform city to named thing. And any function that knows how to operate on a named thing, you can hand it any one of those, and it will know how to go and get the name. And that's all it has to care about. So protocols are ways to group shared functionality. Oh, cool. Yeah. So this is getting pretty fancy. So Matt has moved the print hello function into the name thing protocol. And now if we made a function like why don't you make a free function, not inside there, but like out just outside somewhere, like func make named thing say hello, I don't know. And yeah, so you pass it a named thing. Let's have it take a parameter. Yeah, there's no good way to write the when the verb is at the end, there's no good way to write the name. So this function takes a named thing and runs its print hello function.
Oh yeah, we can do that.
You don't have to print it, it's already going to print.
Right, that function.
Thing.print hello.
Right.
Yeah. So now you could run outside of person, just like, yeah, down there, just like make speak Zev, or make name thing speak Zev. I think I'm going a different direction than you were thinking we were going for this example, but we can make it work.
No, I'm just trying to think about how people in the future will read this. Can't do this here because person's below.
Yeah, I can't use it there because person hasn't been defined yet. You can do struct animal, or yeah, cool. So yes, this is all digression, but it's all kind of wrapped up together. Yes, we could do protocol extensions, but let's not get into that here. Nice. Okay, so there's been a bunch of typing going on, but what's happened here is that Matt has written a function called make name thing speak, and you can pass a pet into that function, or you can pass a person into that function. As long as it has a name, that function knows what to do with it. And this is somewhere along this continuum is the idea that a sequence, you don't necessarily know what kind of sequence it is, but we know it has an element. Specifically in Swift, like there are arrays, there are also sets. There's a few different kinds of sequences, but we know that they all have element. And so any function that knows how to deal with an element of a sequence can work with that sequence. That's all we're trying to say. The playground has other plans. Well, need a counter for times I've had to quit Xcode. I don't know if you have the beta installed.
The Google counter today.
Yeah. I don't know if you have the beta installed. I had a little bit better luck with the Xcode 12.5 beta, but
I don't. I only do betas in the summer personally. which is probably not the best.
Yeah, 12.5 is pretty cool, but also very broken. It's fine. Cool. Yeah. Wow, you just opened it and all the syntax highlighting is already gone. It's great. So right, so that was a very long-winded way of saying that's where element comes from. Element is part of sequence. If you're in a sequence, then you have an element. So we have this function that transforms an element of self of the sequence into this transform type. So instead of for person and people, this is going to be for element in self. Because self is whatever sequence we happen to be on. And then instead of let string equals person.hello, it's going to be let transformed equal transform operating on element.
It's what?
So delete up to the let.
Oh, I see.
The let transformed equal transform of element. And this might be new syntax. So transform parentheses element. So we have this value that's passed in, the transform. And Swift has what's called first class functions. It means that I'll answer that in just a second. Swift has first class functions, meaning functions can be passed around just like variables. Their functions are values, functions are data. You can pass them around, you can do stuff with them. You don't just have to call them. So in this case, we were passed in a function called transform, and then we're running it on element, and then we're appending it to the output. So the question was from the chat, can you reiterate the bigger picture of why you would make this more functional programming like? Is it more parallelism and scalable? So we're just doing this as an exercise. You would never actually rewrite map in your own program because there's already map. I just wanted to give an illustration of how map is written because I think it's a useful exercise to one, to understand how it works, and two, to see how we took some code that was special purpose, right? We had our array of strings, we looped through our people, we got the name out, and we appended to the array. How you can basically just change the types of those values and put it in a function like this and turn it into something that's more generic and more applicable. Obviously, you wouldn't do it with, wow, your Xcode's really unhappy tonight. You wouldn't do it with map specifically, but you might, this can hopefully give you a new lens to look at your own code through, where you look at your code and you go, oh, I'm kind of doing this thing where the structure of the logic is kind of independent of the types that are used. So maybe I can decouple them and have the structure of the logic over here in this generic function and give it a closure, a function that does some transformation over here. And this function can kind of marry them together. Xcode, what are you doing?
Yeah, there was a weird system error. I'm not used to the. Was this High Sierra?
You're on Big Sur.
Big Sur, thank you, man. Where did my brain go years ago? I'm not used to the Big Sur notification sounds yet, but that was like a weird gong sound that I heard.
Yep.
It's not the usual error sound.
Yeah, cool. So that was a bit of a whirlwind. To recap, we have rebuilt the map function for entertainment purposes only. Closed course, do not attempt. No, actually do attempt. This is really cool to play with. And actually, to that question, you could play, like, as an exercise for the reader, try making a version of map that is concurrent. That does, like, if you're familiar with some of the ways you can do concurrent parallel stuff in Swift, it's a fun futile exercise to do. Can you make a version of map that like runs all those transformations in parallel? So that's a fun thing to try. Cool. So from here, originally, throw any more questions in the chat if you want, just to close up this section. But originally, I was going to talk about filter next, but there's also flat map and compact map, which Matt, you had brought up. I kind of figured they're a little on the esoteric side.
Yeah, let's save those for the end if we have time.
Cool.
I think getting the basics of functional programming helps before we start getting
Yeah,
in the
cool.
weeds of it.
Okay. So the next one I want to talk about is filter. And like map and filter are two, like there's a few others, but they're really like the sort of bread and butter of like, oh, these are two very powerful and sort of universally applicable concepts. So it's really nice to both understand how to use them and see how they're built under the hood, because that's a cool exercise. What is up with your autocomplete? Wait, can you quit Xcode and kill your derived data? I feel like somehow that might help. If you're new to iOS development, this is something to get used to. Derived data is like where Xcode keeps its like scratch files. Like it caches your build while it's working, so it doesn't have to rebuild each time, and a bunch of other random caches and stuff. And sometimes, and by sometimes I mean like 10 times a day, that data somehow gets corrupted or messed up in a way that usually you'll see either stale errors, or your thing won't build, or syntax highlighting will die. In this case, syntax highlighting is coming up and then going away, which is super neato.
I also see it a lot with interface builder projects where you run the simulator and you see old stuff
Yep.
blown away, derived data, and sometimes even the module cache will help you out with that.
Yeah, it looks like we're just going to be flying without syntax highlighting for much of the rest of the evening, and we're just going to have to deal with that.
It'll come and
go. Okay, and yes, I think we'll try to get to flat map. If we don't get to it, the quick version is that there's flat map and compact map, and one of them, they basically both flatten a level of nesting. Sometimes that nesting is like nested arrays, and sometimes that nesting is optionals. I can never remember which is which, so I type one and let Xcode tell me if I get it wrong. Yeah.
Yeah, it
compact
used to
map
be
is the one that's optional.
It used to
It
be
used
that
to both
we just,
be flat map.
Yeah, and then they made it more clear
by making it more confusing. Exactly.
Yep.
Cool. So filter. So map was. Oh, hang on. One more question. Would you say map, filter, flat map are how you mostly use functional programming, or do you implement it more widely beyond those particular functions? So I would say yes, for me at least, it's mostly those. I think the more esoteric aspects of functional programming is more up to your style. Like there are programming styles where you would go out of your way to use the functional stuff more. And if you're of that mindset and your team is of that mindset, cool. Like more power to you. Get the book, do the thing. Check out Point Free. They have some awesome stuff on like getting really deep into the functional style. But I think for sort of typical Swift, like day-to-day Swift that you would expect most Swift developers to like be able to sit down and pick up easily, it's not super heavy in the functional stuff.
I'd also say functional programming is relatively new to the Apple ecosystem. There have been libraries that help you do it, both for Objective-C and Swift. But recently Apple rolled out the Combine framework, which kind of replaces some of those, and so I think you'll see functional programming grow in popularity. I also, like Zev, pretty much keep it to map and filter. Mostly because when you start getting more fancy or more close to proper functional programming, debugging becomes a little bit harder, at least for me. If not, like once you've had experience with it, totally, like you probably can see the matrix and understand it all. But it does start to get a little bit hairy the deeper down the rabbit hole you go.
Yep. Not to discourage, like it's really cool to experiment with this stuff and figure out places that it can be useful for your stuff. And one of the main reasons we're teaching it is that it's really nice to be able to sit down in front of some code that uses a more functional style and sort of muddle your way through it. Even if you don't like fully get all the concepts, you can, hopefully you're picking up some skills here to learn how to like break down a function and see what its components are and kind of trace through and see how it works.
I think a lot of people too will argue, going from, what was that, 6 lines of code to where was our map?
It's right below. It's so small you can't even see it.
Yeah.
You're making my point.
Yeah, to this. So we reduced this code by half. So a lot of people would argue that this is better. They both work. Pick the one that works best for your brain.
Yeah, and there's definitely like cases where one is clearly better than the other. Like sometimes you'll have to mutate something and bail out early, and like, oh cool, you can't do that with map, or can't do it in a clean way with map. Or like sometimes you just want this cute little one-liner because it's not any interesting code. It's just like take this array of things and pluck out a property. Don't want to waste any breath on it. Map is a great option for that style. So yeah,
And I think
take a pick.
Once we get through filter, we can show some fun stuff that you can do with it that is a little bit more on the functional side without
Totally.
still going too weird.
Filter. Map was given an array and a transformation from element to new type, return an array of the new type. Filter is given an array and a predicate, a function that goes from, well, you can see it right there, is included to bool. So should this element be included in the result, give me the just the first, or give me all the things in the array that passed that test. So let's again do the non-functional version first, and then we'll go from there. And let's switch from using people to using integers. We don't want to be excluding people here, so let's use integers instead. So let's let integers equal, and then let's just do a sequence from 0 to 100, or a range, I mean. So this is a Swift type called range, or maybe this is closed range. It's a sequence. This is where some of that protocol stuff is pretty useful. Like the closed range from 0 to 100 does not actually contain all those numbers like in memory, but it can represent them, and you can iterate through them and check whether it contains and all the other cool sequence stuff. So it's a pretty neat use of protocols. So let's say we want to pull out the multiples of 3 from those integers. So without filter, the old school way would be, so let's make a var multiples of 3, which is an array of integers. So right, 0 to 100 is not an array. You can make it an array if you wrap it in like array parentheses and put it in there, but no, it's a type called closed range. You can look at the Swift open source code on the internet and see how it works, but the gist is that it has a lower bound and upper bound, and then you could think through. It's like a fun exercise to go, well, okay, how would I implement like a contains function? Well, okay, if I'm asked if it contains 37, I can go, well, is it greater than the lower bound and lower than the upper bound? Okay, yes, then it contains it. So you can do all the, like, as long as it's a type where you can, how many are in between two values, you can basically simulate all the collection operations without actually needing all the values, which is super powerful. That's not a thing anymore. Maybe they renamed it. That's not.
Oh yeah.
Oh,
it's got to
so
be.
you actually want number dot is multiple of is a more modern expressive way to write this. So instead of number.
Nope, mine still works.
Yeah, it does work, but I think in terms of readability, number dot is multiple of 3.
I didn't know that was a function now. That's way nicer than modulo programming.
Totally. Okay, cool. So we had multiples of 3 as an empty array, loops with the numbers. If the number is a multiple of 3, then we append. And that's cool, right? That's perfectly fine. But now let's show the fancy functional version. Oh yeah, if people aren't familiar with modulo, it's basically the percent sign means the same thing as, oh no, sorry, it doesn't mean the same thing. The percent sign is
it's to calculate remainders.
It's right, it's divide these two numbers and tell me what the remainder would be. And if the remainder is 0, that means it went in evenly. But now we have a function for does this go in evenly, and it's called is multiple of, which is nice. Okay, so let's do the fancy functional version. So that's going to be like let multiples of 3 filtered equals.
Such a long variable name.
Yeah, I spend the rest of my night typing otherwise. Equals, and then we'll do numbers dot filter number in, or number to bool in, and then same test, number dot is multiple of 3. Cool. So we have some of the same advantages. It's more compact. I mean, less code is not always better, but in this case, it gets rid of some cruft. It's a let. So once we've made this array of filtered things, then we know that it's never going to change out from under us. It's always going to be the value that it is initially. And it's just in general clearer to see what's going on. You don't have to, I mean, once you get used to it, right? It's always like, wait, what does this do? So, oh, I see filter. Okay, the next thing I see will be run each time and put those in the result. So we could go through the same exercise to build filter if we want, just to see how it works. If you think that's too redundant to the previous, maybe make that an exercise for the reader.
Yeah, I feel like that's a good take-home assignment.
Cool.
Instead,
if you have questions, come in the Discord.
Let's talk about shorthand.
Sure. Yeah. Yeah, so let's actually, the shorthand. Oh yeah, okay. So yeah, quick digression into shorthand. So let's go back to the wow, I'm just looking at what I had in my notes for long version, and it's basically what you've been considering short version because there was some stuff I forgot about for long version. So let's write out what like the longest possible way to write a closure. So let's do the people.map person.name example. Just as an example closure. We can just write it again where we are down at the bottom here. So yeah, let's say we wanted to map out the names of all the people in the array. So the longest possible way you could write this out. So let's add parentheses around the curly braces.
Oh yeah.
And let's add a type for person. Person returning string.
I don't actually know the syntax for that. Is it this? Or do I need a
colon?
Yeah.
Yep. And then returning string. And then in is person.name, return person.name. Oh yeah, we didn't even introduce the term higher order function.
I think you quickly said it at the very beginning.
Oh, did I mention it?
Yeah.
Okay, higher order functions are, I don't even know if this is the exact technical definition. I believe they are functions that deal in other functions. I don't know if it's specifically taking or returning, but yeah, higher order functions like are functions that operate on functions. Instead of just passing in a value, you pass in a function. A function that takes a function as an argument or returns a function. Hey, so it's either one. Hit the Google button, Kronk.
I've been using it for the restart Xcode. I believe
not that Google button. Why do we even have that Google button?
So that people can know that we're human.
How do I know if it's higher order function? So if the parameters include a function, or if it returns a function, it's a higher order function. If the parameters are just like string, int, other normal type, then it's not higher order. Or if it returns, yeah.
Also, function or a closure. So we could actually, we could replace this entire closure with a function, and maybe that's a fun exercise we can do after this.
Right. I have some of that in my notes for later if we get to it.
Let's do it.
Okay, so anyway, we're talking about closure shorthand. So closures, there's a bunch of cute little shorthands in for closures. Like I don't know why we ended up in this place where like closures are the thing where you can just keep cutting out stuff, but basically you can take advantage of Swift's type inference and say a bunch of the characters we just typed are not necessary. Should we jump straight to the shortest one, or like let's chop things off?
Let's chop things off so that people can sort of find the one that they like the most.
Yeah, and we're doing these in n order, but you can do them in a different order. So you're going to run out of words that mean things between long and short, so maybe just number them. It's smaller closure underscore final underscore. Okay, so you can take out the parentheses. That's an easy one. There are certain cases where you can't, but in general, it's a little bit nicer. It's just tidier, like not as much noise. And this is something called trailing closure syntax. Oh, that's actually you can put that in the name. This is trailing closure. So trailing closure is if a function takes a function as its last argument, you can ignore the parentheses and parameter name if there is one. So it makes it look more like an if or a for. Like it's designed to make it look like control flow, which is kind of interesting. They tweaked that recently because there's some Swift UI stuff where it's not just the last closure, but basically, yeah, just pick up the parentheses if it's the last closure. So then we can, it can infer the type person because it knows that you're taking an array of people and mapping it. So you don't have to put person colon person. You can just do person in parentheses. And you don't even need the parentheses. You need the parentheses if you're going to be specifying the type, but yeah, so you can take off those parentheses as well. So now that cleans up this nice, cute little argument list. We can then take off the return type. If it can figure out the return type based on what you do inside the closure, you don't need to say what the return type is, which is kind of neat. Hey, look, syntax highlighting is coming back, like flowers in spring. You can take off the return, the word return, if a closure or a function only does one thing, then you don't have to say return. It just is assumed that you're returning, which is cool. And then finally, you can take out the parameter name entirely. And underscores are different. If you underscore, then you can't actually access it, and we actually do want to access it. Underscore in Swift generally means don't use this thing. But so we take that out, and then we just call it $0. $0 is shorthand for the first argument that was passed in. And if you're dealing with a closure that takes multiple, and then you can put it on all in one line just for kicks. Yeah, $0, $1, $2. If you're dealing with functions that take more than one argument. I can do one better.
Oh.
If you're talking number of characters. The way to do one better is to use a key path.
Oh, yeah.
Which is slightly out of scope for tonight, but still kind of neat. So you would actually do, you do parentheses instead of curly braces, and it's \dot.
Ah.
Yeah. So that's the shortest that you could get it. Key paths are a neat separate topic. Do you think making functions shorter like this might make it more confusing for other programmers? Oh, looks like somebody has come in to say goodnight.
Oh, good night.
Hello. She's very sleepy. All right, I'll hold her for a few minutes. She can join on the stream.
Okay.
Hopefully this is boring and puts her to sleep. Can you stand by in case I need to give her back?
So that is a great question from Ice Magic. Do you think making functions shorter like this might make it more confusing for other programmers that might need to use your code?
Yes, absolutely.
Well,
not absolutely.
Opinion based, yes. Zev and I are both of the opinion, yes. I think when you start getting down to this level, it makes it hard, especially when you don't have good names for your variables. Like if this was just R, like what is the name of an R? So you kind of need to find the balance of what works for you if you're working on your own project, or what works for your team if you're working on a larger project. I've worked on a team that straight up had a rule that we did not allow $0 because we had some weird named things and we always wanted to know what was inside of it. I know other people that love this so much that they would never give it up, even at gunpoint. And very opinionated. My opinion is that makes the code harder for someone that doesn't know a whole lot about the code, wasn't there when it was written, so come back 3 years from in the future, who knows what this is. Obviously our case here is pretty simple. Like it's pretty obvious that people have names. But when you start getting onto larger projects with more complex data structures, um, more complex functional programming chained off of things, which we'll probably get to, it does become more and more difficult to read, and you sort of need to, in my opinion, balance readability against debuggability, or you're balancing number of lines or number, even in this case, number of characters against readability and debuggability. And I think that is to each their own, and the discussion to have amongst yourselves.
There's some good rules of thumb that I try to live by. One of them is that code is read more than it's written. So saving yourself a few characters when you're typing isn't really worth anything. Like, don't be lazy. Do a little bit of extra typing because you want to shoot for clarity when someone's reading it. And that's a skill to develop of like, what is someone else gonna see when they don't have all my assumptions and they're reading this code. As for some of the shorthand things, one rule of thumb that I like is that a variable's name needs to be more descriptive the larger its scope. So like, you'll have a little bitty for loop with like an iterator called I, and that's kind of fine. Yeah. She's had a bit of a rest. Okay. Discover and read more. So yeah, it's good night.
Good night.
It's more important to have like good variable names and stuff the longer lived your variable is. So on that last example, or let's take names 8. It's an array of people because, as Matt said, that variable is named well, and then $0 is like, oh, okay, it's a thing from that array, so it's a person. I do tend to shy away from using $0 unless it's like literally a line that's that short in a production app. If it's anything more complicated, or if it's going to appear anywhere except the beginning of the line where it's like visually really close to the array that it's in, yeah, it's a good idea to give it a name. If you can add a little bit of text to add a ton of clarity, like naming that person makes it a lot clearer. So I'm in favor much of the time, especially if you look at some of the Swift UI things. There's plenty of places you could use $0, but people tend not to because Swift UI closures get like really tall because you're defining whole views inside them. And $0, you quickly get lost as to what things are. So yeah, it's a balance. It's good to, like, you're going to need to know how to read the shorthand because it'll come up, but you can decide for yourself how far you want to go down that road. It's nice to know what your options are. Oh, and let me plug the site I maintain. Let's go with the WorkSafe gosh darn closure syntax.com. You can figure out the other one on your own. But it has some of this documented. I got to overhaul it. I think it could be a little tidier. Yeah, anyway, so that's a little digression into closure syntax and shorthand. Yeah, this one has stuff around like using operators as functions and $1 and $0 if you have multiple arguments. So a bunch of cool stuff. So one thing I wanted to do, if we go back to filter, is we've talked about we've so far been doing inline closures. So inside the curly braces, we've just been writing code, right? So inside there, you actually do the work of whatever the work is. In this case, figuring out if the number is a multiple of 3. But one of the really powerful things you can do here is that you don't have to pass in what's called a closure literal. You don't have to pass in, you don't have to do the work right there. You can pass in a variable that is itself a closure that does the work somewhere else. The simplest version of this that if you've ever worked in UIKit, you probably have done without realizing it, it's kind of along the same lines, is button actions. When you say, add target to a button and you give it a selector, and it's saying, hey, when you when you get tapped, go run this function over here. It's technically not exactly the same thing, but it's along the same lines of here's a variable representing a function, go run that function. So what I'd like to do is, instead of doing like is multiple of 3 inside it, let's make a function, or a closure actually, called like is multiple of, let's do 5. Let's do let is multiple of 5. And it will let's do a function first, like a func, literally func, and then we'll do a let and see how those compare. So func is multiple of 5, and it will take an integer as a parameter, and it will return a boolean indicating whether it's a multiple of 5. So easy, nothing fancy here. And now let's look at the signature. Actually, if you could undo that for just a second, because it's cool to see how these pieces fit together. This is one of the most pleasing things about functional programming, is you get the types to match up, and they kind of fit together like Lego pieces. It's really neat. So look at the signature of what filter is expecting. It's expecting a closure that takes an int and returns a bool. And we happen to have a function. Functions and closures can basically be used interchangeably. We have a function called is multiple of 5 that takes an integer and returns a bool. They have the same signature, therefore they can be used in place of each other. So you can, instead of calling is multiple of 5 inside curly braces, you can pass in a reference to the function. I like doing underscore colon there, which is like the fully specified name of the function, so there's no ambiguity. There's some angry posts on the Swift forums about stuff around that. Did that work? Let's see if that worked. Yeah, you can see it over in the sidebar. We've got our counting by 5s there. Wow, playgrounds. It's almost so good. Yeah, so we have taken a reference to a function and passed it in directly to a function that was expecting another function as a parameter. So that's neat. Let's do the closure version of that. So let's do just to go over the syntax. So we're going to make a local closure. So let let's do, I don't know, is multiple of 10. I don't know. And let's specify the types out front just so we can see, like colon. This is a function that will take an int, or sorry, closure that will take an int and return a bool. And in this case, there's very little difference between this and the is multiple of 5 above. You don't want to make this one self-calling. So yeah, just same thing inside, return. So you can either give it a name with an in list, or use $0. I think everything has to be inside the curly brace. So get rid of num there and do num in.
As you can tell, I never do it this way.
Yeah. So I mean, this is a bit of a like an academic example. So what does the equals mean? So right, so we're making a variable. This is the cool thing about closure syntax. Like it looks like all this fancy syntax, but it's actually the same as doing like let x equals 5. Let is multiple of 10, colon, the type signature. So that's the int arrow bool thing, equals the value. And the value of this variable is the stuff inside the curly braces, including the curly braces, because the curly braces are how you write a closure. So it is literally just variable assignment. It's just that the type of the variable is a closure that takes an int and returns a bool. And the value is a closure that takes an int and returns whether it's a multiple of 5. So these things definitely get, like, we're packing a lot of concept into these variables.
I lost my closure.
Sorry, it should be num dot is multiple of. Yeah. 10. Yeah, cool.
There we go.
Pour one out for Xcode.
Yeah, so that's one of those heady topics that kind of comes with closures, which could be a session in and of itself. We're kind of grazing it a bit, where you can make variables that are closures. We've talked about functions that can take other functions. They can actually return other functions, which is all that higher order stuff. It can get pretty hairy pretty fast.
Can we get one level hairier?
But before we do,
Yes.
so even though this starts to get a little bit hairy, Zev kind of talked about it, where like this does make code a lot cleaner, where maybe you have another 100 lines of things between this and that, or you want to reuse this a bunch. There's a lot of reasons to do what we've just done, but
Yep.
you do get a little bit more hairy each time you do it, and each time
yeah,
you get
and
a little bit
obviously
deeper.
like the is multiple example is pretty classic because it's like short and easy to write. You wouldn't actually write things with these, like you wouldn't make a closure just to see if something's a multiple of something. You would use this for like I think a common case I would think of is let's say you're trying to filter out some objects from a list, and your criteria for filtering are super complex. Like maybe the user has selected a bunch of filters and typed in some text and checked a bunch of boxes, like a product filtering on Amazon or something. You could build up a closure that represents all of that logic, and then pass that closure into a filter. For example, that's like a place where I could see actually using something like this potentially in a real app. Okay, so the going one level deeper version of this is we've written a couple different functions that all do the same thing. They all check whether a number is a multiple of a different thing. So the only thing that's different between them is the multiple, right? We did a 5, we did a 10, we did a 3. Wouldn't it be cool, for certain definitions of cool, wouldn't it be cool if we could make a function that makes functions that can tell if something is a multiple of whatever number? So I called this make function to check if is multiple of. Make function to check if is multiple, and then in parentheses of divisor. And this returns not a value, but it returns a new function that takes an int and returns a bool. Yeah, those parentheses are good. You can write it without those extra parentheses, but like it's weird because you like, is the arrow, is it the first and second and third? Like, yeah, so parentheses are good. So we're going to return a new closure. So the very first thing you type after the return is curly braces, and then that will have an integer in. Integer dot is multiple of divisor. Yeah, and thanks JoeCab15 for suggesting or plus oneing the closure session. I think that would be. I mean, we're kind of doing it now, but we could go deeper. So what have we done? So let's make a new variable. Let's do like let. Sorry, yeah, I said variable, but yeah, let is multiple of 4 equals make function to check if blah 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 4. And let's check out what the type is when the playground runs and we get our little printout. Or yeah, you can option click and see the type of this variable. It's not an int, it's not a string, it's a function that takes an int and returns a bool. So now we have a function generator. We can make as many of these multiple checkers as we want without having to write the whole function out, num dot is multiple of, pass in a thing each time, because we've wrapped up kind of the same thing we did with writing map, right? We were doing this work and we found a way to sort of pull out the common element and write a function to do it for us. This function doesn't take a function.
Yeah. takes a closure, which we were interchanging with function.
No, it doesn't take a closure.
Ah, you're right.
We can make it take a closure.
No, please no.
Saving this for next time, but there's actually some really cool stuff you can do if you make it take a closure, because then you basically, if you make this function, like for people who want to Google stuff, if you make this function take a closure and a value and then apply that closure to the value, and then you make it generic, so it's not int and bools, it's just A and B, that's called currying, and it's really cool. Just gonna leave that aside. Is that currying?
Yeah, I think so.
That's not exactly currying. That's related to currying. What's the memory and resource impact of closuring like this? So theoretically, it depends. Sometimes you can end up in cases where you're like duplicating a bunch of stuff and passing a bunch of stuff around because you're not like modifying things in place. But Swift has some pretty cool tricks up its sleeve to prevent that from being a problem. For one thing, the compiler can sometimes optimize this stuff so it's not actually there in the compiled code. I've seen this amazing example where somebody had an array and they like mapped it and filtered it and did a couple other things, and the compiler figured all that out and just returned a 4. Just like, don't actually run any of that, because at compile time it can figure out that this all evaluates to 4 and just return a 4, which is neat. Swift also has a neat thing called copy on write, where values are not actually copied until you change something. So even if you pass a value around a bunch of places, there's only one of them in memory unless you end up changing it. So that can make a lot of this stuff more efficient. If you're concerned about performance, I mean, this kind of thing causes performance issues so rarely in the type of apps most of us are writing, like iOS apps that are moving views around the screen, because like we're almost never doing things locally on device that are like memory and calculation intensive. So I wouldn't worry about it. Profile your app and do fix it if you notice a hotspot.
If you go check out our session on Combine from September, you can see a lot of functional programming inside of that. And so you can see sometimes when the compiler is super nice and just gives you 4, and you can see sometimes when the compiler freaks out and doesn't know what is life. So definitely find the balance. I kind of said it here, like none of what we have shown today is necessary. It's there to make your code a little bit nicer if you find this nicer.
Yeah. Just to round out this example, just one more line we can do. We can pass this this function that we made into filter. So, numbers.filter is multiple of 4. Actually, if you could write it as a new line, just so we can see that we've made a variable, and then we can pass that variable into filter.
I'm sorry, what?
So undo that last thing.
Nah, not Omega.
And then on a new line,
I see what you're saying.
Numbers.filter. Is multiple of 4. Yeah, so we made a function using our function maker, and we passed it into a function that expected a function of the right shape, and everything just worked, which is pretty cool. And you can kind of see that it's going to work because all the types match up, which is very pleasing. Yeah. So other than flat map and compact map, that's the end of my notes. We can talk about stuff people have questions about, or go in more detail, or end it early if people are bleeding out their ears.
So there's one more thing that I think might make this a little bit more enticing, because we have talked about sort of like the dangers of this and like be careful. There are benefits that do make a lot of code disappear.
totally. Did you have an example in mind, or you want
Not
me
at
to throw
all.
something together? Cool. Yeah. So chaining. So yeah,
Oh, I got
we
one.
showed those examples.
I got one.
You got one?
Yeah.
We showed those examples before of like, it's not that much code to make a variable array and then loop through a thing and then append stuff to the array. But what if you wanted to, what can you say before typing it out? What's your, oh, cool. Even multiples of 3. So we want to find all the numbers that are multiples of 3 and multiples of 2.
Mm-hmm.
Right?
Yep.
So we want to filter by, and let's, ignoring all the like make function stuff, you can just do filter $0 dot is multiple of 3. And then filter again, although mathematically there's a cute way to not have to do this twice, but pretend we actually do need to do 2 separate things. Mathematically, if it's multiple of 2 and multiple of 3, it's multiple of 2 times 3, so you could do 6, but that's not the point. And when you're doing these chains, it's nice to put a new line before each dot. It makes it actually a lot easier to read. No. I go with what control I tells me, which is auto indent. Yeah, which is that. Yeah, so if we were writing this out longhand, suddenly it becomes a lot more apparent how beneficial it is to be able to condense this stuff down into cute little one-liners, because you can chain them together. And when we could actually, let's throw a map. Let's square them. Squared even multiples of 3. Yeah. Because then at the end of this, we can do dot map $0 times $0, and also put that on a new line. And can you throw an extra space after the 3 close paren, or I will claw my eyes out. Cool. So this is like, this
Sarah,
is,
thank you so much for those 5 gifted subs to the community.
Wow, thank you. This would be kind of a nightmare to write out longhand, and it's so, I think, so much easier to go, okay, we're only passing through the multiples of 3 and then only passing through the multiples of 2, and then multiplying it by itself and putting the result in an array. It's all the juggling of things into and out of arrays is handled elsewhere, so we don't have to deal with that. We can focus on the logic, and all we needed is a few verbs to, to think about the concepts of pass only certain things or transform all the things with the same transformation. I'm just going to close the door here.
We're getting spammed with alerts.
Yeah, and the chaining stuff, like, we've only really talked about map and filter. By extension, compact map and flat map also go in there, but then also reduce is one that we can get into if we want to, but it's a little more esoteric. I don't think it comes up as much, but you can throw a reduce on the end of one of those chains, and it's pretty nice because, yeah, again, it's just focusing on the logic, not the, it's
we can even, yeah, so there we've talked about map and filter. Those are just 2 of many of these higher order functions. So there's also reduce, there's sort, sorted.
Oh yeah, sort is great.
Filter with, filtered. There's a bunch of these things.
Yeah. Do you want to, I don't know, where should we go from here? Reduce is cool. I'd love to talk about reduce.
Sure, we can do reduce.
So we've talked about applying a transform to all the elements in an array and returning a new array of the transform. We've talked about taking an array and only passing through the elements that pass a certain function, test, a predicate. Reduce is another tool in your tool belt for sort of taking lists and arrays and collections of data and doing something with them. And in this case, what reduce does is it squishes all your values down into a single value using a transformation that you provide. What does that mean? So by example, you could take an array of numbers and get back the sum of that array by describing how to add each value to the next one. Or you could get the product of the array by describing how to multiply. You could do some fun stuff with string concatenation. Let's do a couple examples, and then we can maybe talk about sort of their commonalities. So let's not call it sum, because I think we're going to end up needing that name for a couple other things. You could say sum of square even multiples of 3.
Oh god. I don't want to do the squared one just in case we get large numbers.
Sure. So equals, so you take that value, dot reduce, and let's do this out longhand, because until you understand reduce, the way you write it could be really confusing and surprising. So let's write out longhand. So we'll do reduce open curly brace. Initial result. So reduce 0, and then in the curly braces, let's do result, comma next, returning int, in result plus next. What's going on here? So reduce, actually let's longhandify this further. Instead of using trailing closure syntax, let's actually name the second parameter. And let's name it die xcode die. I bet a restart. Once you finish, I bet a restart will make it a little happier.
I do have,
yeah, so if you...
I have an update to run.
Oh yeah, it's called next partial result. It's the parameter name. Or is it underscored? I forget.
Nope.
Yeah, there you go. Is it like that? Yes. No. Okay, it's not a named parameter, so it doesn't help us to have that written out twice. So never mind. But that's what the closure represents. So what's going on here? Let's talk about what's happening. So reduce takes an initial value. You always need an initial value. There are ways people have talked about not needing an initial value, but the idea is, in this case, we know we're adding, so we want the value that basically means you have added nothing, so 0. So the mathematical term for that is the additive identity. If you want to think back to high school math, it's the thing that you can add without changing anything. And then we get a closure, and what this closure is going to do is it will give us a rolling result, like you might also call it an accumulator. And if we were writing this out long form ourselves, we would make var sum equals 0, and then on each iteration we would add to the sum. But in this case, it just gives it to us, and we teach it how do I combine an item with the how do I combine in the next item with the result. And in this case, we do just regular old plus. And what's really neat here is that do an option click on reduce. Even though it's using generics, it's going to tell us the specialized. It's called specialized when you like plug in the types. It's kind of doing it. It's not telling us that result is int, but we know result is int. But it's saying, okay, I'm going to take an initial result of type result, which we know is int, and a next partial result. This is the important part. It takes two ints and returns an int. Again, it's annoying. You can't really see that from here, but if you option click the values in the code, you'll see that they're both ints. Like, yeah, next and, oh, okay. The type of next is annoyingly obfuscated. You can't option click those to find the type, but in Xcode 12.5 you can, which is exciting. But anyway, this is a function that takes two ints and returns an int. It turns out Swift already has a function built in that takes two ints and returns an int representing their sum. It is the plus operator. The plus operator is actually a function that operates like that. So there's this really cute shorthand where you can do reduce 0, plus, which is like, you think you learned how to read Swift, and then you come across this line and it's just like, what am I looking at? What is happening here? And what gives it away is if you option click the plus, you'll see the plus is static func plus, takes a left-hand side int, right-hand side int, and returns an int. So it's just a function. It's spelled a little funny. It's not spelled with letters, but it's a function that takes two ints and returns an int. And it just so happens that reduce is expecting a function that takes two ints and returns an int. So, as with most things in functional programming, if the types match up, it doesn't really matter what they are. You can just mush them together and they work. So it's not like, I don't know if there's anything in Swift in particular that they had to do to make this possible. It's just sort of a neat consequence of the fact that operators are defined as functions and the signatures match up. So that's really neat, I think.
Yeah, they've given that example too with like sort, where you could just do it right off of this. No,
you won't be able to sort the.
It's not an array. We can do it off of this.
Oh yeah, I know what you're talking about. Yeah, sort takes a closure that gives you a left-hand item and a right-hand item and says, hey, tell me which of these two is, I think, the smaller one, or whatever. Yeah, the smaller one. And you can do that with a closure where you do stuff inside the closure yourself, or you can go find a function that you happen to have lying around that is of the same shape. And the greater than operator is a function that takes two ints and gives you a bool if the left one is smaller, or whatever it is. I guess the right one is left one is small. Anyway, you're always going to get it backwards no matter how hard you think through it.
Yeah, so doing that one little line reversed our array, which is super cool.
Not the most economical way to reverse an array.
Absolutely
you should call .reversed if you want to do that, but kind of neat. Yeah. It's useful for other things. Oh yeah, just to give an example of reduce, not with numbers, because I think the numbers can, if you're not a math person, they can kind of gloss over the it's more performant and also more expressive. Like sorted by greater than only reversed it because we knew they were already sorted to begin with. Anyway, yeah, let's do one more example of reduce using strings, just for a slight change of pace.
Mm-hmm.
So let's make a string that's just a sentence, like with spaces. You could take any of your comments and paste it in as a string. So let's do the meme thing of putting a clap emoji between each.
God.
And so that you could do it with, there's a couple different ways to do it, but let's do the functional one because that's what we're talking about. So let's do sentence.split.
You want to do this in place, or do you want to do this separately?
It will be, I don't think there's an in place version.
Well, I'm saying, like, do you want it up here?
Oh, no, let's leave sentence as an array, as a string, and then do a new thing. So, yeah, so let's do sentence dot split, and then the separator will just be a string. So this will give us each word in an array. And then, so technically not an array. There's things and stuff and things about Swift's protocols and strings and stuff that are, I'd love to talk about if people have questions, but otherwise let's keep going. And then we're going to reduce. Initial result will be the empty string. I think there's going to be a slight problem with this, and we can talk about that. But yeah, so then this is result next, returning the final thing will be a string. So the arrow result is string in result plus space clap emoji space next.
Nope.
Command control space to type emoji.
Command control edit option. What's up, the other Daves? What's your question?
Oh, I think I said we can talk about this if you have questions. So
It's not giving me the emoji.
Command control space.
Command control space. Not giving me the emoji. Might be because escrow is drunk again.
Yes. That's it, right? Yeah.
Yeah.
Control space.
There it is.
Cool. So yeah, clap. Yeah, let's see if that. I think it might give us an extra one at the beginning that we don't want.
It probably will, yeah.
Yep. And that's so here's the problem. The other Dave S or the other Daves. I don't remember what I said. Like I remember that I said something if you have questions, but I don't remember what I was saying. So remind me and I will, or if you give me the questions, then I will answer. Yeah, I know it's based on the thing I said, but I'm tired, okay? So yeah, drop first is a way to do it. It's a little annoying to like add the things and then drop the first one. So instead of reduce here, you could use joined and pass it as a separator, and they're probably using reduce or something like it internally, but then just not doing it on the first one. But so, maybe this isn't necessarily the way you would do this because joined is a more expressive version of this, but it just shows you like you can use it with any type. Oh, technically they're not strings. Thank you, Jing. Yes. Definitely not related to functional programming or closures, but kind of neat, just like fun little piece of Swift errata. If you option click on split, you will see that it's not returning. You would expect it to return an array of strings because you're taking a string and splitting it into what is basically an array of strings. But yes, the other Daves, you're correct. I'm hinting at string versus substring versus string protocol. And if you're interested in digging into this, there's this really cool document that used to be called Swift String Manifesto. If you Google that, you will get to the actual file, which is now called String Processing for Swift 4, which I can paste in the chat. So the stuff I'm going to tell you I got from that document when I read it a few years ago. It's pretty sweet. They were trying to decide like how should string work in Swift, and the main thing here is when you split a string or you chop up, like you pull out a piece of a string, you say, hey, give me index 1 to 10 of this longer string. It doesn't make a new string. It gives you a special type called a substring. And what a substring does is it stores a reference to the original string and then says, but only get from this index to this index. And if you think about it, like if you have a string representing the complete works of Shakespeare and you trim off the first character, rather than incurring a copy and making a whole new string of the complete works of Shakespeare, it's just saying, hey, that string over there, but every time you ask for index 0, give me index 1, and index 2 isn't like it does this index translation. So you're holding this little thing that feels like a piece of the like it feels like its own string, but really under the hood, it's keeping the original string alive and using its storage, which is cool because it means you don't incur extra memory copies until you actually need them. Because you could be, pulling out this substring just to check its length and never actually like using it somewhere. That means you're not, copying a bunch of extra stuff all over the place. Or in this case, we were pulling out the substrings and then adding them right back into the main original string, or adding them into a new string, but we didn't have to copy them out and then copy them back in. We only did the copy when we actually used them. So that's really neat. But there's an interesting side effect, which is that because it's a specialized version of I don't know if it's slice is substring is the subsequence. So every sequence has a subsequence, or most sequences. It's an associated type of the sequence protocol. Every sequence has a subsequence. So it says, hey, if you slice into me, you're getting this thing. So for array, if you slice into an array, I think there's an array slice type. So basically same thing. If you slice into data, you just get data. It doesn't do this stuff, or if it does, it's on the it's behind the scenes. You don't see it. Matt, you're gonna have a hard time doing that on an empty array.
I don't think slice exists in Swift.
So it's slice. There you can index into an array if you do like 1 2 3 brackets dot dot, like sorry. So 1 2 3 then open bracket, square bracket. Let's do 0 dot dot less than 1, or dot dot less than 2. Yeah. So just that. Don't do anything after that.
Gotcha.
And let that whole thing and see what type it is. What type is that? Array slice.
Gotcha. I was thinking about the function slice. Yeah.
Right. So again, same thing. It will give you back a special collection that is actually secretly just keeping the original array alive, and just giving you a view into some of its indices. And so there are two surprising things here. One, it's keeping the original array alive. So, oh, hey, look at that. Long-term storage of array slice instances is discouraged. A slice holds a reference to the entire storage of a larger array, not just a portion it represents, even after the original array's lifetime ends. Long-term storage of a slice may therefore prolong the lifetime of elements that are no longer otherwise accessible. So it's basically a memory leak. So use this in your algorithms. Use this as you're kind of going between one thing and another, but don't have your function like return an array slice and then store it off somewhere in some long-lived cache or whatever, because it's going to keep the whole original array alive. Same thing with string. So like once you're done with it, wrap it up in a real string or a real array to not do the copy. So in this example, that would be like let actual array equals array parentheses that thing, and then it will copy it into a real array. The other thing, which they also mentioned in that document, is is that slices preserve their indices, which is another thing that's surprising. So if you let's do, instead of 0 to less than 2, let's do indices 1 2 3 4 5, just so we have a few more numbers to work with. And instead of 0 to less than 2, let's do 2 dot 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 in the so not 0 dot 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 2, but 2 dot dot dot.
Oh, sorry.
Yep. So check the type on that. The dot 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 is half range, half open range or something. It's like from the start, from 2 to the end, basically. So that's okay, right? That's expected. The type of this is the subsequence of an array of int, and we can go and trace that through and figure out that that's an array slice. But here's the funny part. Print out this whole thing dot indices. You might expect this to be 0 1 2 or however many items there are in the array, but instead you will find that Xcode is terrible.
I've never had this much trouble with the playground.
It's weird.
Yeah. I think Xcode doesn't like streaming in playgrounds. So I think we had similar in past meetups.
Love having to set automatically each time you open it. It's probably a security thing. Like, you don't want this thing just randomly running code because it could totally hose your system if you had some bad stuff in it. Yeah, so the indices, oh, make an array of the indices. Actually, no, you can see it right here. The indices of the subsequence are 2 up to less than 5. That's a little weird, right? You would expect like, oh, I would expect like, index 0, index 1, index 2, but no, slices preserve the original indices. I forget the exact explanation of why this is. It's something transforming the indices, or something. If you do like a search on the original array, it's nice to be able to reuse those indices. I forget exactly what it is, but like if you do this whole thing brackets 0, you would expect to get like the 2 or the 3 or whatever, off by 1 error, but you would expect to get like the start item. But see what happens if you, Matt, what do you think we'll do if you do this whole thing brackets 0?
This whole
to
thing
get the 0
brackets.
Like on a new line. What would you expect to happen?
I would expect 3 to be the thing printed.
All right.
Sub-0, yeah?
Yep.
Yeah, I would expect 3 to be the thing.
No, the answer is error. Index out of bounds. So because slices preserve their indices, you are looking at items 2 through the end of the array with indices 2 through the end. Index 0 does not exist in this slice. Confusing, right?
Yes.
But if you wrapped it up in an array, like array of this whole thing, bracket 0, that resets the indices. This whole thing was perhaps not the best choice of name.
It's also that I'm now at the point of the meetup where I'm super tired, and it doesn't matter what you'd say. Like, what are you saying to me?
Yeah, there you go. So that resets the indices because it's like making a new array with new items in it. But yeah, so sub slices are really cool because of the efficiencies they give us in terms of memory, but it's definitely what they call a leaky abstraction, which means like, even though it's trying to hide away the details are totally not hidden away. And you totally still have to confront the details. So the more you understand about those details, the less likely you are to make mistakes.
Cool. I feel like that is a good place to call it a night because we're both tired. Mm-hmm. We've covered a lot of things, and we definitely have gone into weeds deeper than we had originally intended. And
I've seen a couple questions or things come in on Discord. I haven't had a chance to dig into them, but as soon as we're off the stream, we'll go and follow up on those. So if anybody has other stuff they want to chat about, I'd love to see you in the Discord, the link for which is in the chat right now.
Discord in the chat. You can also do exclamation point links in the chat. You can catch our YouTube channel. So if you missed any portion of this meetup, in 2 weeks, I will have it uploaded to our YouTube channel after I've gotten around to doing some editing on it. And if you can't wait those 2 weeks, you can still catch the VOD here on this Twitch channel for the next 2 weeks until Twitch automatically removes it for us. I want to thank everyone. I especially want to thank Dan, Ice Magic, and Nime HDI for your follows, and a big thank you to Sarah for the 5 gifted subs out to the community. The questions tonight were amazing. This is, like I said at the head of it, a very difficult topic to sort of grok, especially the first time you're seeing it. So if you do have those questions, or you're just kind of like completely mind blown, please do hit us up in the Discord channel. We're happy to help, not only with this, but anything that you might be coming across in your journey learning Swift. Next month, which the third Thursday is April 15th. On April 15th, we'll be back here on this Twitch channel again at 6:45 p.m. Eastern time, and we're going to be talking about some tips and tricks on how to better use Xcode. If you have followed Zev, he usually does this with hot peppers. We're not doing that this year. It's up to you if you want to eat a hot pepper. I'm not going to make you do it. But there are a lot of neat little tricks that can make your day-to-day use of Xcode more enjoyable than I think most people know. So we'll see you next month or in our Discord. Everyone have a wonderful night. Be safe. Watch out for snow that I think we're supposed to get tonight if you're in the Boston area. And keep learning things. See you next time.